Ground-penetrating radar, or GPR, is a geophysical technique that can be used in archaeology to conduct non-invasive site investigations. GPR can be used to quickly map a site for excavation or to locate potential cultural resources in a way that minimally impacts the site. This allows archaeologists to target areas with buried anomalies, which reduces the time and cost of sampling and excavating. GPR collects and records information about the subsurface by mapping and measuring physical or chemical changes in the ground. These can include hearths, buried architectural components, or even areas where archaeologists have excavated previously. A basic GPR unit consists of three parts: a transmitter, a receiver, and a control unit.
This is a shielded antenna, so it's got a transmitting and receiving antenna built into one. Where Greg's antenna has these two antennas that are separated, so one transmits and one receives. This has them both in the same unit. What we're looking for is the reflections back into the other antenna. So it's going to go out and reflect off things and come back. And the amount of reflection is measured on here in different little hyperbola, little features that you see on the screen. And what the computer does later on is pull all that stuff together and tell you where the more dense areas and less dense areas are.
There are many different types of surveys that can be completed with GPR. One example is a 3D survey. The operator runs the GPR on a predetermined grid over an interesting area, collecting data along the axis.
So what we got to do is collect a lot of different slices of the data across. They're called radargrams, slices across the area. And then what we'll do is we'll switch this grid around and do them the other way as well. So we'll have a 3D cross-section of the grids. And then what the computer does is it interpolates in between those and creates a map surface or a time slice.
The view of the subsurface produced by the computer can reveal potential anomalies. GPR can be a useful technique for archaeology because it is quick, relatively cheap, and only disturbs the grass you're walking on.
It provides you with some way of at least getting some reading of what's below surface. It's not like a perfect map. It's not it's not like MRI, like a doctor would have. But it gives you some parameters as to where some of the features may be located, where some of the anomalies are, where some of the things you might be want to locate are. Historic sites, you can tell you where foundation piers are, or basement features, things like that. And prehistoric sites, like Shillman, you can tell you where areas of higher density are or lower density, where different occupation episodes may be in a mound. You might see different zones where things have been built up or taken off, and you can investigate those. We're working on a site right now out in Lake George that is now just pasture, and it looks like an orange grove. And we can actually see the shell rings and the various other features below surface based on the GPR. So it's kind of cool.
If you'd like to learn more about archaeology or about the publicly accessible archaeology sites in Florida, go to www.flpublicarchaeology.org.